All right, so we know that we've learned in previous chapters about the inverse of a function. And what we also learned is how to tell whether a function has an inverse to begin with. And we said that if the function passes the horizontal line test, then yes, it does have an inverse. So for example, if I have a function, the graph of which is something like this, and if I apply the horizontal line test to this, right, meaning I draw a series of horizontal lines and they will only cross the graph at one point at a time. If it passes the horizontal line test, then yes, it has an inverse. If it doesn't pass the horizontal line test, then you say no, it does not have an inverse. Now, if you graph a sine curve, this is what it looks like, and you can clearly see that there is no way this is going to pass any horizontal line test because it keeps going up and down. Any horizontal line is going to pass through the sine curve multiples of times. So that sort of limits us. To get around it, what we do is we restrict the domain to negative pi over 2 to pi over 2. So rather than taking the sine curve from negative infinity all the way to positive infinity, if I just go, like this is negative pi, this is negative pi over 2. If I just go from negative pi over 2 to pi over 2, then all I have is this part of the curve, the sine curve. Now, if I apply the horizontal line test to just the highlighted part, is it going to pass the horizontal line test? Mm-hmm. It is going to pass the horizontal line test. So when we talk about the sine of x function, or cosine of x, or tangent of x, we restrict the domain from negative pi over 2 to pi over 2, so it is possible for it to have an inverse function. Now, when we talked about inverse functions, remember if I had a function f of x, the inverse of it was f minus 1 of x. Okay? The same notation is going to apply here. So if I talk about the inverse sine function, the notation is going to be sine to the minus 1 of x, or I can call it arc sine of x. Now these two are totally differentiable. They mean the exact same thing. Okay? So the inverse sine of x, or the arc sine of x, is the inverse of the sine function. Okay? Now, what does it mean? The way we read it is y equals the inverse sine of x. And what it means is this. If I have y equals inverse sine of x, that means sine of y is equal to x. Okay? So if I take sine of this one, it equals to x. All right, so what does it mean in practicality, in application? I know that the sine of 60 is root 3 over 2. We all know that now, right? Because we can do this with our eyes closed. If I tell you the sine of 60, you imagine the unit circle, you imagine a 60-degree angle. The opposite is the longer leg, which is root 3 over 2. So the sine of 60 is root 3 over 2. Now, suppose I asked you a question. Suppose I said, give me an angle that when I take the sine of it, I get root 3 over 2. What would you tell me? What angle, if I take the sine of it, will give me root 3 over 2? The answer is 60. That's the inverse sine. So if I were to say inverse sine of root 3 over 2, what I'm saying is, give me an angle that when I take the sine of it is root 3 over 2. And the answer is 60 degrees.
So this is the same as when we were in the beginning of the unit, when we were using our calculators.
The notation is summarized in this domain. So we have arc sine, which is denoted as inverse sine or arc sine, and we have arc cosine and arc tangent. Now here's something important. This particular book happens to capitalize the A's here and the first letters here. This is This is just notation specific to this book. Nowhere else have any of us ever seen this. So ignore the capitalization. We are never going to capitalize. We're never going to capitalize. All right? Ignore the capitalization. Okay. So let's go in here to some of these examples. Now the first one says to find the exact value of each expression. And the first one is inverse sine of root 2 over 2. So think to yourself, okay? Inverse sine, first of all, sine is associated with the y. And it's positive root 2 over 2. So think to yourself, what angle, okay, has the y value at root 2 over 2? What, the corner of what angle? The 45, right? The 45 degree here, because it's root 2 over 2, root 2 over 2. Well, is there any other one?
Isn't it every 45?
What about the one here?
The one below, quadrant below.
145, 135.
So this one is 135. What are the coordinates here? It's negative root 2 over 2,
And
positive root 2 over 2. So this one definitely works. Will it work down here? Down here, y will be negative root 2 over 2, so that won't work.
yeah, but
Okay.
positive what?
The only angles that will work is if they give us a y value of positive root 2 over 2. So that has to be above the x-axis. So either 45 degrees or 135 degrees.
So it doesn't matter about the state calculus thingy.
It does. All students take calculus. So you want the sign, right? Sine is positive here because all of them are positive here.
Oh.
And sine is positive here. So it's the ones in these two quadrants.
Okay.
Absolutely it works. Okay, so here I want the inverse sine of negative root 3 over 2. Here's my unit circle again. Negative root 3 over 2. Now if the y is negative, right, sine y is negative, that means I'm in one of these quadrants below the x-axis. So either here and here. Now, root 3 over 2, sine of root 3 over 2, that's associated with our 60 degrees, right? So it's going to be 60 degrees this way. What angle will that be? 240. Or 60 degrees that way. What angle will that be? 300. So it's those two angles. Okay, yeah.
These always have to be shown in terms of like positive, not.
You can go either way. Either positive or negative. So it could also be, negative 60.
Okay.
Now, the arc sine of negative 1.
So to get the second number, you just add 60 or whatever the degree is?
To get the second, no, you have to look within each quadrant. So I know that this is associated with the 60 degrees. So the reference angle has to be 60 degrees. Either in this quadrant, I need a reference angle of 60. Right. So this is a reference angle of 60 degrees. However, the entire angle is 240. Here is a reference angle of 60 degrees, but the entire angle there is 300. Okay? All right, so arc sine of negative 1, that's when our y value is negative 1. Y value is negative 1 at one point only, and that point is 270 degrees. Now, if I were to ask for the radian equivalents of these, you should be able to also provide the radian equivalents. So for example, in the case of these two, the radian equivalent of this is pi over 4. What about this one? 135 in radian. So it's pi over 4, 3 pi over 4. Here, if I'm associated with the 60s, it's all the ones divided by 3. Okay? So it's pi over 3, 2 pi over 3, 5 pi over 3, 7 pi over 3.
Why? Why would it? Why do you have so many?
We have 2, but what are the ones?
Oh, on the top two.
Right. No, I'm just listing all of them. So it's pi over 3, 2 pi over 3, and 4 pi over 3. And what about this one? 5 pi over 3. So the answer to this one is 4 pi over 3 and 5 pi over 3. Okay? And 270 will be 3 pi over 2. Now, in the case of these, we have a bit of work to do. Okay? So, what I will do, however, is I'll probably stop here today